All right, so carrying on with the example from the previous video, we want to take this velocity function and calculate the total distance traveled by the object from 0 seconds to 3 seconds. And to do that, we want to integrate not the velocity function itself, but the absolute value of that velocity function. First thing we can do before we start trying to solve that integral is we need to go ahead and make a sign chart for our velocity function so that we can figure out where it's negative. In particular, we want to know where it's negative so that we know where we need to reverse the sign, right? So that portion where it's negative is going to have a negative, like the integral is going to be negative. So we're going to need to subtract it to cancel out the negative and make it positive again, and then add on the absolute value. So here we go. So what we'll do is we'll first take this v of t function and we can factor this. This happens to factor as 3t minus 2 and t minus 3. So if we set this equal to 0, we have two solutions. We have 2/3 and t equals 3. So those are our two moments in time when it's equal to 0. So now our velocity function v of t will have a sign chart that's going to look like, we'll go from 0 to 3, and then we're going to have that 2/3 somewhere in here. And, you know, check a couple sample points. We'll check like a half and 1 or something, and you'll find we have positive on this interval and then negative on this interval. So that's our sign chart for v of t. Now I didn't show that. You can use your calculator to plug these sample points into the function and get positive and negative. Okay, so do that on your own. But now what this means is that if we want to integrate the absolute value, all we need to do is integrate it from 0 to 2/3, and we'll integrate the regular function because on 0 to 2/3 it's positive, so its absolute value equals just the original value of the function. But then what we need to do is on the interval from 2/3 to 3, if we integrate the original function, okay, not the absolute value anymore, but just its original function, this is going to be negative, right? Because this is the portion where it's going to be beneath the x-axis down here. So what we need to do to counter that is subtract that integral. Okay, so I know this seems a bit counterintuitive because remember we want to add up all of the areas, but what we want to do is add the absolute value, and the absolute value will be the opposite of the velocity on that interval. So that's why we're subtracting it. Okay, that subtraction is to minus, it's going to cancel the negative that we would get from the interval itself, from the integral. So let's see what we have from this. We would have the integral from 0 to 2/3 of our function, 3t squared minus 11t plus 60t, minus the integral from 2/3 to 3, 3t squared minus 11t plus 6. And yeah, I already kind of showed how to do each of the, you know, how to do it the whole way. Like, I don't want to go into I don't want to spend time on the details here, I guess. But, you know, get your antiderivatives, plug in the numbers, do some arithmetic. You'll get 1.85, approximately, 1.85 minus your negative 6.35. Normally, if you do 1.85 minus the 6.35, you would get your negative 4.5, like we got in the last video for displacement. But here we're subtracting the negative 6.35, and we get about 8.2 meters. So that is the total distance traveled by the object, not the displacement. So, okay, that'll do it.